Hello world, hello everyone. I'm actually very excited to have everyone here. We have a lot of people from around the world. I appreciate the fact that everyone joined from just a single post, and we have a plethora of people joining from um all around the world. I really appreciate everyone joining. Once again, thank you for joining this class. So it would be just very nice if we just do a little bit of introduction. Just in the comment section, you could just introduce yourself, tell us your name, and also where you're joining from. All right. So I just thought it would be nice to explain why we are actually um putting out this course. So we've had a lot of people come to us to just explain remote sensing to them because the whole concept of remote sensing look abstract. So we found out that a lot of people don't have they don't have the fundamental knowledge of what remote sensing is. So all what they do is just to get to practicalize out stuff. So now we're trying to just break remote sensing down um like a 7-year-old. So that's like the basic reason we talked about this course. So also would appreciate it if you subscribe to the channel. You'll be helping us a lot by subscribing to the channel, liking our videos, and also we have a Slack channel. I'll drop the description in the box. So we have a Slack channel where we get we are building a community, so you can join us. We will be dropping updates on our Slack channel moving forward. So thank you again for joining the course. Thank you in advance for subscribing to our channel and also joining Slack. All right, so just let's get started to the course. So the title of the course is Demystifying Remote Sensing. So before we move forward, it would be nice to know what remote sensing itself is. So before we just straight out define what remote sensing is, I feel it makes sense to first explain what remote is, then sensing. So when we say remote means, for example, looking at Corona, a lot of us are working remotely, so we don't have to have physical contact with our offices. So we just work from home. So we are working remotely. So remote means something that is at a distance, something that is at a place. So from the definition we have here, we have situated far from or not close or from a distance to an object. So sensing simply means to perceive or to detect an object by sense. So now once we coin both words together, remote sensing, in the simplest term, remote sensing is the acquisition of information about an object without having physical contact with the object, or having any physical contact with the object. So let's just give a more technical definition of remote sensing. So this definition is from USGS. So USGS defines remote sensing as a process of detecting and monitoring the physical characteristics of an area by measuring its reflected and emitted radiation at a distance. So typically by a satellite or an aircraft. So before we dive in deeper into what remote sensing entails, so let's just look at some forms of remote sensing. So I have 4 forms of remote sensing I'll be explaining to us about. All right. So the first form of remote sensing is the camera remote sensing. So we have the camera remote sensing. So the camera remote sensing it generally acquires images within the visible and the near infrared spectra using photographic camera or a digital camera. So it's not really complex. It's just using camera to using a photographic or a digital camera to obtain images of an area. So the camera can be borne either on aircraft or a spacecraft. So for this type of remote sensing, they are usually manned. So there's someone manning the camera. So basically, camera remote sensing is commonly referred to as photogrammetry. So on the image, we have say someone on the aircraft So and the person basically turns a digital or a photographic camera to the earth from the aircraft, and the person like take pictures of the surface of the earth. So that's one form of remote sensing, which is the camera remote sensing. So the next form of remote sensing is the satellite remote sensing. So for this form of remote sensing, we have a sensor. So the sensor um, for the camera remote sensing, the sensor was the camera. So we have a sensor that is actually mounted for satellite remote sensing. We have a sensor. Now this sensor is mounted on spacecraft, like satellites is mounted on a satellite. So the sensor is limited to the visible and infrared region of the electromagnetic spectrum. We'll be talking more about the electromagnetic spectrum like in details next week. So this type of remote sensing basically depends on sunlight. It's the illumination of the sun is where it derives all its energy from, and so since it derives all its energy from the sun, the sensors mounted on satellites are known as sun synchronous. So we'll be explaining more of this in details. So later in the course. So the next one is radar remote sensing. So basically, radar remote sensing is like an observation system. It also has is a sensor that is actually mounted on a satellite. But this sensor, the difference, like the significant difference between the camera remote sensing and satellite remote sensing to the radar remote sensing, that for radar, the sensor system, it operates within the microwave portion of the electromagnetic spectrum. Like it operates within that microwave portion. Like I said earlier, we'll be talking more about the electromagnetic spectrum next week. So do not miss the class. We'll like be explaining it, we'll be demystifying it. So so for that radar, for radar remote sensing, the sensor operates within the microwave portion of the electromagnetic spectrum, and it has its own source of illumination. So remember we said for the satellites, the basic source of energy is the sun. Like it relies totally on the sun for like its energy. So but for radar actually has its own source of illumination. It generates its own energy. So we'll be moving on to the fourth form of remote sensing, which is the natural remote sensing. So this natural remote sensing is just like for us to understand natural remote sensing, we just like have to use our sense organs. So natural remote sensing is the concept is derived from human sense organ. So for example, everyone can hear me and you can hear my voice without having to use like an earhead or without having to put your ear so close, like your ear is not coming in contact with your laptop. Probably you're watching from your laptop or your TV. So you don't have to like you don't have to put your ear against the TV or the laptop to actually hear what I'm saying. So that's like a natural form of remote sensing, because you can sense the information I'm passing without having contact with your device. But if you're using probably an AirPod, I mean it's not natural anymore. But for example, another form of natural remote sensing is our eyes. So we could actually our eyes is another sensor. So you could actually like see what is on the screen. You could see different colors on the screen. You could read what is on the screen. You don't have to like plug your eye so close to the screen to actually detect what you are seeing on the screen. So it is also a form of natural remote sensing. So all our sense organs aside our tongue are different forms of natural remote sensing. So for the skin, you could feel it. You could feel if you could like sense the temperature of your environment. So you could say the ambient temperature is hot, it's cold. You don't necessarily have to like put your body so close to something to like you don't have to put your body so close to say an object to determine the temperature of the room. All right, so and the final one is our nose. So with the aid of our nose, we could actually also sense the smell of object. To like we don't have to like put this object directly to our nose. Like our nose doesn't have to come in contact with them before we can actually sense what we are perceiving. So that wraps up the form of remote sensing. So next we'll be moving on to like applications of remote sensing. So we have like a plethora of applications. We have a lot of them. I would want us to like actually do more research on applications of remote sensing. So this is just like the tip of the iceberg. So we have a lot. So the first one I have here is to determine the soil moisture content. So this is like an agricultural application whereby the farmer wants to know what is like the moisture content in the soil, like say on his farmland. So like it can help aid irrigation decisions and what have you. So you could also use to map different soil types. So it could help aid decisions like what is the best crop to be planted on this particular soil type. So we also have quantifying soil conditions with normalized difference vegetation index. So we have different indexes. So one very useful and common index that is used in remote sensing is the NDVI, which is the normalized difference vegetation index. So basically this gives values ranging from -1 to 1, and it just tells us about the health of the crop. So it tells us about the health of the crop. So values ranging from -1 to about say 0.2 are basically not they're basically not vegetative areas. So vegetative areas range from about 0.2 to 1 depending on how rich in chlorophyll they are. So also going to climate, we can actually compare has the climate been changing from past to present. Remote sensing has a lot of application, monitoring volcanoes, detecting the land use of a particular area and seeing what covers that particular area. Could forecast weathers. You just have a whole lot of applications. So I would actually want us to like do more and do a little bit of research on our own, and we should just discover more ways we could apply remote sensing to our current field. So say you're into the environment, how can you apply remote sensing to the environment? Say you are into your field is the electricity field, how can you apply remote sensing to like optimize what you're doing at the moment? So regardless of what field you are, even medical field, how can you map diseases or monitor the spread of disease? You could just apply remote sensing to a whole lot of fields. So just you could just do a simple Google search and search for ways you could like apply remote sensing to your particular field of study. All right, so we'll be moving on to the process of remote sensing. So the process of remote sensing is just trying to explain to us how like remote sensing happens from the sun to application, like from the energy source, and how we apply that. So we'll just talk about that in the following slides. So I want you to look at the image carefully. So we have the sun, we have A representing the sun, we have B, we have C, we have D. Just take about 5 seconds and just digest the image. All right, fine. So we'll be talking about the process like one after the other. So the very first is the energy source. So the energy source, or it's also called the illumination, and that's represented as A. So the energy source is the sun, and this provides us with the electromagnetic energy. So for example, depending on your time zone, if it's night where you are and you're in a dark room, you don't get to see anything. Everywhere just gets dark. So you probably be looking for an illumination source. You'll be looking for electricity or something. You just want where you are to get lit. So basically, the sun is the sun is serving as our energy source, and it illuminates. It doesn't just illuminate, it provides like the most important element, which is the electromagnetic energy. So it is this magnetic energy, the radiation, that actually gets to the target. And now depending on the depending on the depending on what the target is like composed of, then it like reflects back. So the very and the most important thing is the energy source, which is the sun. So moving on, we have the radiation, and we have the atmosphere. So basically, when this energy is being transmitted from the sun to the earth, before like the energy like reaches the earth, the first point of interaction is the cloud. That's the atmosphere. So the electromagnetic energy interacts with the atmosphere like differently. There are different type of interactions. So we'll be talking about that. Next week. We'll be talking about the different forms of interaction we have. We have scattering. We have, because some of these radiations will be scattered. Some of this radiation will be absorbed. So we'll just talk about all of this next week. So the first process of remote sensing is the energy source. So this energy source. So the first process is this energy source, and this energy like illuminates. This energy illuminates like to the surface of the earth, but before it gets to the surface of the earth, it first of all interacts with the environment. It interacts with the atmosphere. So we have different type of interactions. So we'll be talking about that in details next week. So now the next point of contact is the target, which is our point C. All right, so it interacts with the target. So for the entire process, the first process we spoke about is the energy source. So the energy illuminates like so we spoke about the first process, which is the energy source, which is the sun. So the sun illuminates the energy, which is the electromagnetic energy, to the target. But before it's the target first interacts with the environment, and we spoke about the types of interaction. Some get scattered, some get absorbed, and some just pass through and reaches the target. So now, depending on the property of the target, for example, the targets are different features on the surface of the earth. Myself, I'm also a target. You know, if I'm outside and the sun is shining on me, that's the target. The roads are targets, buildings are targets, trees are targets. What we have a lot of targets, even water bodies, you know. So anything on the surface of the earth is basically a target. So now once the energy comes down, it passes through the atmosphere and it gets to point C, which is the target. So now, depending on the property of the target, depending on what the target is the target a tree? Is the target a what feature is the target basically? So that property determines what happens next, which is it's okay. So for example, for some targets, for some objects on the target, some of them actually transmit the energy back, and some of them just absorbs, just taking like the energy. So now we have another arrow here pointing to the satellite. So the energy comes from the sun, interacts with the atmosphere. It's the target. So now on this target, depending on the property, it sends some objects on the target, sends that energy back to the sensor, where the sensor gets to record this energy. And some of the radiation coming from the sun also gets into, like, pass through the target, like they penetrate the target, not everything, and also the target even absorbs some. So now this target also sends back some of this energy to the satellite, which is what the satellite records. So now this point, the D, is the recording of the energy by the sensor. So the satellite itself doesn't record. The satellite is just a platform for the sensor. So the sensor in the satellite records the energy. So that's what we have here as the fourth step. So we need a sensor that is something remote, that is not in contact with the target, which receives the electromagnetic energy or the radiation after it has been scattered or it has been emitted from the target. So that's like the fourth process, which is like the fourth step. So now the fifth process is the transmission, the reception, and processing. So the sensor's energy must be sent. So whatever this sensor records, whatever the sensor records, it sends that energy back to us on the surface of the earth. Like, it sends it back. So right here I have the sensor's energy must be sent. So usually it's sent in electronic forms to a receiving or a processing unit or a processing station where it's like being converted into an image, so something we could actually relate with. So the energy from this target reaches the sensor in the satellite, and now the satellite and the sensor in the satellite sends back this energy that was recorded on the surface of the earth back to us on the earth again, to a transmission center, like a place where the energy is being converted into like data that we humans could work with, we could interpret, we could assess, and now from there we do some interpretation and analysis. So that is where we come in, we as geospatial scientists. So that is where we come in. So like we process the image, we interpret the image, and then we send this image to applications. So basically what the last part is talking about is how we apply. So earlier we spoke about different applications of remote sensing. So now the last part is now telling us the last process is the application. So after the sun records the energy, it's attached to the atmosphere. From the atmosphere, it hits the target, it interacts with the target as well. The target sends back some energy to the sensor. The sensor records this energy. After the sensor records this energy, the sensor sends it back, and after it sends it back to a processing center, because it is basically electromagnetic energy, and we can't like fully understand what that is, like the nitty-gritty of that. So it has to be like converted into like a digital image, something you could like see, something you could recognize, something you could relate with. Then we start processing the data, cleaning the data, because the data has like a lot of errors and all of that. So after that, and the final process is the application. So depending on on the particular problem you want to solve, depending on whatever you want to do basically, so you extract the information from the image and you use that to like solve your problem. So here I have the final step as application. The final elements of the remote sensing process is achieved when we apply the information we have been able to extract from the image about the target in order to better understand it. Then it reveals some information to us to basically assist us in solving any particular problem. So that is like the last stage. So we are coming to an end of the first class. So is basically just like an overview or introduction to like remote sensing. So we have an assignment. We'll be sending a link whereby we get to like answer the assignments and give our feedback about the class. So our first week assignment is to just differentiate between satellite images, drone images, and digital photographs. So next week we'll be talking more about the electromagnetic spectrum, we're breaking the electromagnetic spectrum down to us. We'll be talking about the different interactions with we're talking about the different interactions of the electromagnetic energy with the atmosphere and the surface of the earth. So that was like basically we'll be talking more about B and C next week. So I appreciate you all for taking out time to join this brief lecture. I mean, it's a whole lot when I see people joining around from everywhere worldwide. So thank you so much. Thank you for joining the class. I hope you enjoyed the class. Don't forget to subscribe to our YouTube channel, and also give this video a thumbs up if it was helpful. And finally, like I said, we are building a community, so do join our community. Do join our Slack channel. We'll be posting the link in the description box. So join our Slack channel, subscribe to our channel. Thank you so much for your time, and we'll see you next week.